Welcome back all of you. So, in previous lecture we studied about the simple matrix method and the remaining two methods of like say matrix used in EIA, the Leopold matrix method and weighted matrix method that we will look into in today's lecture, followed by some examples and finally the comparison of all three types of matrix based EIA methods. So, Leopold matrix, as the name indicates, it is based on the name of some person who invented or designed this matrix based approach for EIA. So, it was designed by Leopold and his colleagues from United States Geological Survey in 1971 while they were working on like calculating the environmental impacts of projects related with the rivers on different components of the environment. They used to gather lots of data on water quality, the river, the flow, the hydrological measurements, and there used to be a lot of environmental components which they listed down. So, the original Leopold matrix, it was designed for hundreds project actions which were represented mainly in the columns and about 88 environmental components, thereby resulting in almost 8800 possible interactions. Okay. And out of these 8800 possible interactions, all of them need not be very significant. So, today like even people wish to use Leopold matrix for doing EIA of their projects, most cases 25 to 50 of these interactions are sufficient or enough to know whether we have included all the important project activities and all the important environmental components or not. So, rows are typically represented by environmental components and columns are represented by project actions, though they may be interchanged depending on the user and the number of components or number of activities. But most common you will see columns represent the project activities and rows would represent environmental components, not just in Leopold matrix, but in any matrix based EIA methods. So, what is the difference between simple matrix and Leopold matrix? So, simple matrix told us whether there is the impact or there is no impact or there is positive or negative impact, that is all. Now, each interaction between a project activity and an environmental factor or a component, it can be evaluated based on two metrics. One is how big or small of an impact it is, that is the magnitude, the scale of the impact. Okay. And second is importance of the impact, that is significance, like how important that particular impact is. Okay. It will be more clear when we take some numerical examples, but this figure here represents that both magnitude and significance or importance can be rated in the scale of 1 to 10, where 1 represents the lower value, 10 represents the higher value. Significance of 1 would mean like least significant, 10 means most significant. Magnitude, though it is represented from 1 to 10, sometimes the sign convention that we use with these numbers of magnitude will represent whether it is going in the positive direction or negative direction. So, plus 1 would be the positive impact, like little positive impact, and minus 5 would be like highly negative impact. Okay. So, these numbers can be used in case of this magnitude 1 to 10, but significance will always be in the positive numbers. Some books would report these scales from like say 0 to 10. When we say significance is 0 or magnitude is 0, it is like a blank space in that matrix. Okay. That particular activity is not at all relevant with respect to that particular environmental aspect. That is the meaning whenever a cell is blank or it has magnitude or significance as 0. Understood? So, meaning of magnitude values. So, the scale is 1 to 10. So, if we go from say 1 to 3, there is a improvement, means we are moving somewhere positively. Moderate improvement, 7 to 10 is a very large improvement, 0 is no change, no effect. So, example of such positive improvements can be like if we plant trees or shrubs along the roadside to like stop dust and pollution, to stop breaking down of roads or soil erosion, then creating sediment ponds, improving the drainage, in large scale afforestation, it will have positive impact on the environment, it will help restore ecology and maintain the biodiversity also. So, those kind of examples they would be having positive magnitude values. Negative, minus 1 to minus 3 small damage, minus 4 to minus 6 moderate damage to the environment or society, minus 7 to minus 7 will be large damage. So, small damage example can be dust or some small loss of vegetation for some short time. Soil erosion, moderate noise can be the moderate damage. Destruction of entire habitat or very heavy pollution, like nowadays we see in Delhi and Noida regions, like AQI has crossed 450, like, or the highest value of the scale which is available. So, it is like a large damage. Okay, it would come into the category of large damage which will have value ranging from -7 to -10. Similarly, the meaning of significance values. If it is 0, the factor is not at all relevant or significant with respect to the components of environment that we are considering. 1 to 3 would be low importance or low sensitivity. For example, sparse vegetation or degraded land or some loss of, say, like grazing land. 4 to 6 is medium importance, moderately sensitive. And when we say sensitive, it is sensitive to whom? It is sensitive mainly the stakeholders or the community or the living components of the environment. Okay? It can include plants, animals and human beings. Mainly it comes related to the society. High importance or high sensitivity would be for ecologically sensitive zones, protected forest, wildlife habitat. These are very highly sensitive matters of high importance. So, any impact on, say, the population of tigers or eagles or the forest habitat would be considered as a very significant impact. Now, methodology for Leopold matrix, it is similar, like first couple of steps are similar to the one in the simple matrix. You define first the project activities, identify and list down all the activities which you think may have impact on the environment. So, for example, land clearance, excavation, mapping, etc. Then identify and list down all the components of environment. Okay, it can be under the category of environmental, ecological, socio-cultural, economic. List on all the components which may get impacted by the project activity. The third is prepare the matrix. Matrix means the table. Okay. The first thing in the table is to prepare the list of rows and the list of columns. So, activities across the top and environmental aspects or components down the side or rows in the y axis or x axis here. Okay. This next step would be identify the potential interaction. So, once you have the matrix, like all the activities and components, so these are the cells which will show if there is any interaction between the project activity and the environmental component. Now, once you identify those cells, you assign magnitude and significance. So, because it is a Leopold matrix, the magnitude and significance will be inserted in the upper triangle and the lower triangle of each cell. So, if this is one cell, the magnitude will come here, let I call it as x, and significance will come here as y. It can be any number between -10 to +10, and this can be any number between 1 to 10. So, you enter the magnitude of impact, say 1 to 10, positive or negative, in the upper left triangle of each marked cell, and then you enter the significance or importance in the lower right triangle of the same cell based on sensitivity, regulatory values, public concern, etc. That is what I told you earlier, like when we talk about significance, it is significance or important with respect to whom? So, with respect to regulations, public concerns, okay, sensitivity to the environment, okay. So, based on that we assign the importance or significance values. The last step would be to review and summarize. So, you calculate the overall magnitude and overall significance scores for either each activity or for each environmental component. So, let us look at one example which will make it more clear. Same similar example which we have studied earlier also, highway construction project. The first thing was to list down all the activities and all the factors or the environmental components. What you can see here is I have represented activities in the row wise and environmental components in the column wise. I did this because the number of activities which I considered was less than the number of environmental factors that I am considering. Okay. So, columns, they are representing environmental components or factors, rows they are representing project activities. This need not be the consistent rule, you can swap the rows and columns also. Columns can show project activities, rows can show environmental components or factors. Now, like I said, like the each cell in the Leopold matrix will be represented like this and not like this. Okay. When you represent a cell, so like in this cell, for the activity of clearance or clearing, the land use has -7 as the magnitude of the impact, and 7 is the importance of that impact. Okay. So, that is how. So, it is represented here as 7 slash 7 -7 slash 7. So, similarly, since a activity has the impact on factor, so it will be easy to read table row wise. So, now the first activity is clearing. So, clearing has impact on land use, soil, it does not have impact on water, surface water, it has impact on groundwater, air quality, it does not have impact on noise. Okay. So, on land use it has the like high impact, but highest impact is on the soil, because it is the soil which we need, which gets directly affected when we clear the land. Then groundwater, because we do not go very deep excavation, the impact may be little less. It is negative, but it is less in terms of magnitude, -2. Air quality may get affected because of the dust and particulate matter. So, it is -4, somewhere moderate impact is there. Now, that is the magnitude of the impact, and if you look at the importance or the significance of those impacts, the soil impact and the land use impact are most significant, followed by air quality impact and groundwater. Now, here like coincidentally it happened that the magnitudes and the importance are following the similar trend, but it need not be the case all the time. Okay. It depends on the project and the components or activities that we are considering. But just like we did entered first row for one activity, for each of the activities like excavation, transportation, machinery, asphalt, you enter all the values. So, when you try to enter the values here in the Leopold matrix, the first thing is to enter only the magnitudes. So, like if this is the matrix, so you just enter the upper triangular values like say -7, -8. Okay. So, in entire matrix you enter the upper triangular values first. Now, once the magnitudes of all impacts is done, then you enter the significance of each of those impacts, that is a lower triangular matrix. Okay. 7, 8, 6. Okay. So, that is the way you go down like step by step. So, first you enter magnitude, then you enter significance. That is how when you complete all the cells, each cell is called as Leopold cell because it is a Leopold matrix. Now, when you enter all the numbers for each activity impact on the different components of environment, you get a big get a final matrix. Now, since they are all representing numbers, they can be added to give us the final scores. So, the final magnitude score would be the summation of all the numbers row wise. Okay. So, here how do we get -21 here, that is -7 plus -8 -2 and -4. So, how much it is? 4, 2, 6, 7, 8, 15. So, it is -21. So, that is how you get the final magnitude. Similarly, you get the final significance, 7 and 8, 15, 15 and 5, 20, 23. Okay. If it is negative, you put the value negative. If it is positive, you put the value as positive. Okay. Here we do not have any socio-economic or public health or safety thing. So, we do not have much positive magnitude impact, it is all negative because we are having different components of the environment here. We do not have any socio-cultural economic factor here. Now, similarly, you do all the row wise additions to get the final magnitude and final significance. What does it represent? So, this final magnitude shows the impact of this clearing activity on the entire environment or all the components of the environment together. This represents the impact of one activity. Similarly, each value represents the impact of that individual activity on the entire like environmental scope, and that is the significance of those impacts. Now, I will change the activity and factor like columns and rows, and let us see how does it look like. Okay. So, now here we had columns shows environmental factors, rows shows project activity, and this is how it look like. Now, the factors are listed here like the environmental components, and the project activities are listed along the columns. That is the most widely used convention, right, the commonly used framework. So, here also like you fill the magnitudes first. I use the same numbers as the previous slide. Okay. So, when you refer to these slides, you will see that the numbers are same as in the previous slide. Now, here the difference comes in the final magnitude and significance, because in Leopold matrix the final magnitude and final significance are always calculated row wise, no matter what the rows are representing, what the columns are representing. The final magnitude and final significance will always be calculated row wise and not the column wise. That is how the Leopold matrix are formulated. So, now here since we did the transpose of the matrix, we switched from rows to columns. First rows had the project activities, now the rows have environmental components and columns have project activities, and these are the numbers of like the magnitude and that is the significance entered similar to the previous table, and the final magnitude and significance, the numbers are different. If you remember the earlier numbers, this was something like say minus 21 and this was 23, but now it changed out to minus 15 and 16, that minus 7, minus 6, minus 13, minus 2, minus 15. Similarly, 7 plus 6, 13 and 3, it is 16. You can do it for each of the row and you can get this numbers which shows the final magnitude and final significance. Now, how do we know which one is correct? Actually, both are correct. Okay. Does not matter where the factors and activities are placed, the final magnitude and significance will be calculated like this, but there is a meaning which these values convey in each of the two types, and those are, suppose if the activities are in the rows and the second option is the components or environmental components of factors are in the rows. So, if activities are in the row, each row is equal to one activity, right, and so if these are the activities along the row wise. So, each row will represent one activity A1, A2, A3. So, and sums are done row wise for Leopold matrix. So, the interpretation would be the total impact of each activity on all the factors combined. So, now if suppose environmental factors are say F1, F2, F3. Now, A1 will have some values here F1, F2, F3, and the total sum of this x will be the addition of these three numbers. So, this will represent the impact of activity A on all the factors combined. That is what the interpretation is. If you have activities in the row, the final magnitude or significance will represent the total impact of each activity on all the factors combined. And now, other way around, if we have components or the environmental factors in row, like say F1, F2, F3, that is the environmental factors row wise, and activities will be here A1, A2, A3, and if there are suppose 3 numbers, the addition of these 3 numbers, it represents the impact of all the activities on a single factor of the environment. Understood? The addition of these 3 values will represent the impact of the total impact of all activities on a single factor. For each row it will be like that. That is the representation. So, none is wrong. You may have projects in the row, project activities in the row, or you may have environmental components in the row. The representation, the interpretation of the final values which are always calculated row wise in a Leopold matrix, that would be different. So, like if we have rows show project activities and columns environmental factors, so this will represent what is the total impact of this activity on the environment, total impact of like each activity or one activity on the overall environment. And if rows have environmental factors and columns have project activities, it will represent what is the total impact on this environmental factor or each environmental factor from all activities. So, that is the difference. Both ways are correct. You can represent project activities or environmental factors row wise or column wise, does not matter, but make sure when you deal with a Leopold matrix and you enter the magnitudes and significance in each cell for that matrix, the summation of all the magnitudes and of all the significance is always to be done row wise, and then you list down separately in a column the final magnitude and the final significance, and that will give you the total or the final magnitude and significance for the entire Leopold matrix. Hope that is clear. Continuing with some examples now. Second example, hydropower plant project. Now, there are different activities involved in a hydropower plant project which will have impact on different components of environment, soil, water, air, noise for sure, and because it is for generating power, it may have impact on aquatic life, some human income, society, power, all those things. Then there are many activities involved in hydropower plant, that is clearing site, excavation, dam building, river diversion, turbine operation, road building or road construction. And so, these are the activities and these are the impact or the factors or environmental component: water quality, aquatic, soil, air and socio-economic. Okay. Just to have it fit in this one slide, I have included limited activities and limited environmental components. Do not assume that this covers all the activities in the hydropower plant project and all the components of environment which may get impacted by hydropower plant project. No, it is not. I have just shown here limited number of activities and limited number of environmental components. So, as you can see here, most of the values showing impact of each of the activity on different components of environment are negative, okay, except for the ones on the socio-economic, that is +1, +3, +6 and +4. Like in socio-economic also we have something like for the because of the diversion of river, maybe it impacted the fishermen's jobs or activities and it had some negative. So, those the first value represents the value in the upper triangular part of the cell and lower triangular part of the cell represents the importance or significance. Okay. So, you fill all the values for the project, for the hydropower plant project, and that sums up the Leopold EIA matrix table for hydropower plant. Now, you can do the total final magnitude and final significance. How much this comes out to be? Like, does it match to -21? Just check. -4, -5, -2 and -7 and -3. So, 5, 4, 9, 2, 11, 7, 18 and 3, 21. Similarly, for 7 plus 8, 15 plus 6, 21 plus 9, 30 plus 7, 37. That is the final magnitude, that is the final significance. Now, what is the physical meaning of these final magnitudes or final significance? Actually, right, just looking at this table, the final value, see when you look at this individual cells, it does give us some idea, but to answer which of the activities is having most environmental impact, it is easy when we look at the final magnitude or final significance values. So, here one can clearly tell that water quality is the most affected environmental component and it is the most significant one also. The socio-economic is the most positively affected environmental or social component and significance is considerable for that also. Okay. So, that is why this final magnitude and final significance helps. Now, that was all about the Leopold matrix. We saw like how it is different from simple matrix, and it just each cell in a simple matrix has got now two entries in the form of upper triangular and lower triangular value, where upper triangular one is the magnitude of impact and lower triangular one is the significance of the impact. Significance is also sometimes called as importance or weightage. Okay. That is why when we extend that Leopold matrix thing here, the next matrix method type for EI is called as weighted matrix method. It improves upon the simple matrix or the Leopold matrix by assigning weights to environmental components, allowing a more realistic and prioritized assessment. So, you may find some weighted matrix methods where in Leopold matrix, like instead of giving say significance to each environmental component with respect to each activity for each cell, we can separately have a list of significance for each of the environmental components and assign it equally to each of the activities. Okay. But let us leave that aside for a moment and continue with the Leopold matrix method and how do we extend it to a weighted matrix method. Okay. So, for each cell, weighted score would be magnitude into significance. W represents weightage, okay, M into W. So, like now if this is a Leopold cell where the entry is say 4 and 5, in a weighted matrix method this will become 20, 4 into 5 20. If it is say minus 4 and 5, this will become minus 20. Okay. That is the entry into the weighted matrix method. So, final weighted score is usually again row wise. So, once we have individual cells like this, okay, in a matrix, the final would be the addition of all the entries row wise. But unlike in Leopold matrix method where irrespective of you have projects activities on row wise or column wise, the final magnitude and final significance score would be calculated row wise only. In weighted matrix method that is not the case. You can even do column wise totals, okay, they are optional and they can give us some additional interpretation. The method is flexible. Most EIA practitioners select column wise totals or row wise totals or a mixed combination of both based on their project needs. Okay. So, now let us continue with the previous example of hydropower plant. Again the numbers I have kept same as in Leopold matrix. So, this gives you the impact or environmental components, water, aquatic life, aquatic ecology, soil, air and socio-economic, and these are the activities in the hydropower plant project. Now, in Leopold matrix, this cell, this particular cell would look like minus 4 and 7, but in weighted matrix method, this becomes minus 4 into 7 is equal to minus 28. Now, that is the final score of this particular cell. Similarly, minus 5 and 8 in Leopold it looks like this, but in weighted matrix these are multiplied to give a minus 40. So, similarly, all the entries in the matrix can be filled by multiplying the magnitude by the significance and keeping the sign as it is, whatever sign is there for magnitude, we leave it as it is, and the final weighted score would be the row wise addition of all the entries. But like I said, it though most common like approach or the tradition has been doing row wise summations to give us the final weighted score, sometimes it can be done column wise also. But again it is a matter of representation or what information or insight we want to convey or generate from this EIA matrix table. Now, when we look at all these final weighted scores for this particular project, you can see if I ask you which is the most like impacted environmental component by this hydropower plant project, the answer would be aquatic ecology followed by water quality, right. Aquatic ecology is the most negatively affected, just followed by water quality. And which one is the most positively or net positively impacted? That is socio-economic impact is the net positive. You can correlate it from the final weighted scores. And the relative difference between the two score values can tell us like this minus 164 and 1, it is not very far from each other. So, there is I will not be wrong if I call them okay, both of them are most negatively affected, both the water quality and aquatic ecology. So, that is how these final weighted scores help. Now, if we do the column wise for the same matrix, I have taken the same numbers minus 164, 166 plus 89, these are the row wise sums. Now, for the same matrix if we do the column wise sums, what is having, it gives us the final weighted score for each activity. Here it gave for each impact or environmental component or factor. Okay. So, this shows basically all the activities of the project or the entire project has effect on water quality, this much, and here it shows one activity of site clearing have this much effect on all the components of the environment together. Excavation has this much effect on all the environmental or socio-cultural events together. So, if you look at the values, it shows this river diversion has the most negative impact on most of the environmental components. Now, it may happen that this river diversion is directly connected to aquatic ecology, because aquatic ecology is the one which is mostly impacted, and this is the activity which generated most of the impact. So, this tells us where to focus our mitigation efforts on. It is because of river diversion mainly that water quality or aquatic ecology got impacted. So, we need to do this river diversion very carefully, so that these impacts are minimized. Okay. It is the interpretation, again it is similar to the Leopold matrix when we had shifted the rows and columns to project activities and environmental components, but here it is slightly different. We do not shift the project activities or environmental components rows and columns, but if we do the row wise weightage, it tells us which environmental components are most impacted, and when we do the column wise summations, it tells us which activities of the project cause the most impact. So, that is how the two interpretations are different. So, for here example, when we do row wise, it tells us which environmental component affected, aquatic ecology and water quality. When we do column wise, which of the activities caused the highest impact, river diversion and excavation, yeah, -1 minute. So, that is how both row wise, column wise summations deliver different interpretations. So, that was all about matrix based EIA methods. Today we saw like Leopold matrix method and weighted matrix method, and in the previous lectures I think we studied ad hoc method, checklist method and network method. Today we covered matrix. There is another method called overlays or GIS, which we are not covering as a part of this course, because there has been a lot of lectures already on the environmental impact assessment and its methods. But anyway, this was one of the major components of this course. So, if we have to do the overall comparison of different EIA methods, so these are the methods that we studied, including and one additional is there, overlays or GIS method. The type of all these methods is qualitative, matrix is semi-quantitative, GIS is spatial because it is based on remote sensing and GIS data. The key feature of ad hoc method is the expert opinion method. Okay, it's and checklist, it needs a lot of information, so structured list. Network gives us a cause effect relationship, so there is a flow of impact, the connection from primary to secondary to tertiary impact, or connection from project activity to the environmental impact. Then activity component table, it is represented by different types of matrix methods. GIS is map based, that is the key feature. The strength of ad hoc, it is a quick and simple, but limitation it is subjective. It may get biased depending on the experts or the stakeholders that we choose for doing EIA. Checklist, it is comprehensive compared to ad hoc, but there is no interaction between any project activity and environmental component. Then in network, it shows the indirect effects, but it needs lot of questions, like a lot of questions needs to be asked, lot of data needs to be generated to establish proper links between project activities and impacts and different categories of impact. So, it is very data heavy. Then matrix, it shows us a cause effect relationship between the project activity and environmental component. Limitation is when the number of project activities or the components of environment increase, it gets really complicated, and sometimes the impacts or the components are not very easy and straightforward to be ranked between 1 to 10. Sometimes two components would be very close to each other, and if you rank it 1 and 1.1 or 1.2, it will add to like computational complexity also. And in overlays or GIS, the strength is it's visual, it's accurate because it makes use of remote sensing GIS software, but then again it needs lot of data. Without those images or the GIS data, we won't be able to do the overlay or GIS based EIA method. So, to summarize today's lecture, we started with Leopold matrix method, where the project activities typically mostly given in the columns and environmental components given in the rows. Okay, that is the activity, and each cell is called as Leopold cell, where the upper triangular matrix represents the magnitude and lower triangular matrix, lower triangular value of the Leopold cell represents the importance. In weighted matrix, we just replace this x and y values by x into y, okay, and then the thing is same. But in Leopold matrix method, always the sum is summation of impact magnitudes and significance is always row wise. For weighted, it can be either row wise or column wise. Both row wise and column wise summations will have different interpretations, and then we looked at different examples for each of these matrix methods, and finally we did see the comparison table for all different, like I think 4 types of EIA methods that we covered in this course, and so like how each one can be helpful with its own strengths and limitations. With this we stop here for today. Thank you.